Alright, hello. Welcome to the weirdest lecture of the semester. Sorry this video is out a little bit later than expected. It took a little bit longer than expected to get better. So this one is all about shaders. And I'll just kind of jump into more or less the overarching concepts here. There's no slides, but I will be providing a bunch of examples. Hopefully my computer doesn't crash, but I've got like 6 different instances of Unreal open, and we'll take a look. So what are shaders first and foremost? Well, the goal here is for us to come up with some kind of pipeline that our assets are going to follow when we're actually developing. So we've already kind of looked at 2 different types of pipelines, one being creating our substance designer materials and one being, creating trim sheet materials, and both of those kind of fall into different pipelines. One thing in common between them though is you can do both very easily with a similar material setup. So we came in here and we made our materials for these things, and if you look at the trim sheet setup, it is incredibly simple. We just have our color, metallic, roughness, opacity, and normal, just going straight into our actual outputs here. So this bit obviously is controlled by Unreal Engine. Anything that they have in here is something that's built in, and the actual outputs along here will change depending on the material type that we select down here. So if we change our shading model to something else, we'll see that different options are available to us. So now we have clear code options available as well because we've switched to clear code, right? That might be really good if you're doing something like a car or something with a screen that has some kind of coat overlaid. For us, the default lit is just fine here. So at any point in our creation process, we can kind of stop and think to anywhere that we can not only automate, but just expand or change the way that this functions. So at the end of the day, all of these different texture maps and all of your different mesh data, your UVs, your geometry, your vertex colors, everything like that is just data. And so there are a bunch of different things that we can do with this, and that's going to be team by team. So rather than going through nitty-gritty examples with you, because I don't think that's going to be super useful, I wanted to use this lecture to examine all kinds of different ways that this stuff might be used in different environments, both in our example projects and in actual game scenes. So I'm just going to real quick make sure that this is using the right... Okay. Perfect. So this example I use every year, and that's going to be Skyloft from Skyward Sword, one of the Legend of Zelda games. It's an older game, but a lot of the principles and stuff that I'm talking about apply really well here. So let me just minimize everything so my computer doesn't crash. This website is called NoClip, and it's an incredibly useful resource for, well, getting B-roll for YouTube videos, or just generally examining how they've made environments like this. So we can get a pretty good idea of all of the different things in the scene, and we can turn off individual textures, models, and all kinds of other things. So if I just click on some random texture, for example, we can see here exactly what the texture map looks like, what resolution it is, its name, and if I just kind of fly around, eventually I'm sure I'd be able to actually find it in the scene as well. One reason that's great is because we can get an idea of the workflows, practices, pipelines, and shaders that they actually used to create a lot of this detail, and we can replicate that in Engine for ourselves as well. So I'll just open up a second layer here with all of the palace details. They use very similar methods as well, as we've learned things like modular building pieces, things like trim sheets, right? We see these repeating details where they're making use of trims and different UVs. This texture is here for the bricks, and then it's cut here into some other texture that's being used somewhere else. Don't know exactly which one, but more or less these are all using some trim textures. This game is old, and as such you'll notice that there aren't any shadows in the game. And part of that's to help with the painterly look, So this is all going to depend on exactly what kind of look you're going for, but part of that is also just restrictions with computing at the time. How they actually got around that is they decided, hey, we have this extra data available to us in the models themselves in the form of vertex colors. So what if we use vertex colors to actually power our shadows? So you notice we do have shadowing on buildings like this, but if I go ahead and start removing, let's see, if I remove the textures from these models, you'll notice how much detail is actually just painted into these models using vertex colors. If you're not familiar with what vertex colors are, essentially every model in Blender here has the ability to be painted by vertex. It's a very rudimentary form of extra data storage, but we can then in an engine separate that information out and use it as a mask, right? So it's kind of almost like a texture map without any UVs or anything, right? It's just going to indicate to us colors on different vertices. So down here, if I drop into vertex paint, I can change a color, choose something like turquoise, and paint an individual vertice. All right. So in the case of something like Zelda there, they're picking nice shadow colors, something a little less saturated maybe. And then they can go in and kind of paint on where these objects should be shadowed, right? And just like that, we get a nice kind of gradient up from the ground. You're not limited to any one color, and you can do whatever you want with that information. For example, if this one I have cyan, yellow, and magenta, in my shader I could tell it, hey, this cyan part should be one material, this magenta part should be another material, and this yellow part should be another material, right? Just start lerping between the values that are shown here in the vertex colors. So they've done a few different things. I did mention the shadowing, but there is something else they're doing with the vertex colors as well, and that is using it to sort of hide transitions between different elements. So let me see if I can find an example quickly. Something like right here, we're seeing where the vertex color starts to fade off. We're actually using that in conjunction with some trim textures to just kind of hide where something starts and where something ends. Right? You can see it here between the two different objects, one just being an object that is here with this sort of leafy texture with opacity on it, and it's just helping blend it in to the environment behind it, so it's not so obvious that it's entirely a different texture and mesh. And then to show you that, I can actually go in here and find the model itself, since there's not that many, right? And we could take that off. So because this is an older game, it is exported entirely as one mesh, other than anything dynamic, which is fine. But it does make it a little bit harder to tell exactly where they use modular pieces and things like that. But we have those vertex colors, and then that secondary mesh on top to help blend everything together. So this is a great example of one way that you can use things like vertex colors, but there are an infinite number more ways that we can use this extra data. So I'll show a couple more different projects. This being last year's project. Here are two more ways that we can sort of figure out different opportunities to use shaders and pipelines and things like that. In this case, we have these details that are repeating throughout the scene, and I wanted to make use of blueprints, so it was really easy to make changes to these large pieces since they're repeating over and over again. But as a result, I'm left with this one particular part where each individual one of these is going to have its own title, and rather than creating a different mesh for every single title and having to swap out that mesh every single time, since this is always going to be consistently in the same spot, what I did instead was create this shader that actually grabs where the object is in the scene, multiplies it into some kind of value that I can use as an offset, and then actually offsets the UVs. So I'll go over a little bit about each individual node in Unreal in a bit, but essentially it's going to take the UVs that it samples and just add to them. If I pull up Paint to make some rudimentary example, a UV grid is still, at the end of the day, just a two-dimensional grid, right? And we have our values U and V. So if I was to create an offset of 2 and 4, the calculation would end up being the same as any other two-vector calculation, where my U value would, gain 2, and my V value would also gain 2 or 4 as an offset. So you can imagine if I had a UV here and I added 2 on the U, it would actually just move over here. So combining that with a texture that just has all of the different names spread out equally, I can reuse this multiple times, and actually for other details or any details that need to be repeated in some kind of order. So the exact same thing worked for these letterings on the side as well. Another use is, in this case, we use trim sheets just like we did for the live in class example. And with these trim sheets, one thing that does happen is every single piece does start to look kind of the same. They're using the same textures, you're using the same materials on everything. But we can create things like additional masks and use those to drive other kinds of aspects of our materials. So in this case, if I crack open this again, you'll see my default material for this version of the project is much more complicated than the one that we made this year, just because this kind of project actually necessitates it. So you can see here there's a bunch of stuff going on, and here is a mask for all kinds of other random values. This RGB mask here. This RGB mask isn't totally necessary, but what it allows me to do is just go into Substance Painter. If I was in Painter, for example, I can go ahead and just paint random different masks onto these objects that I can then drive in the shaders. So if I look at this one, for example, I've got a channel for dirt, which then gets passed into the shader, right? And the way we build up these black and white masks here in Painter to use them within Painter, we're essentially doing the same thing, just instead of using them within Painter, we're exporting them into Unreal and then having the shader drive them there, right? Because we need that one set of UVs to be handling the trim sheet, we need a separate set of UVs to be handling this kind of stuff. So one for dirt, one just to highlight the edges to help the shader create some edge wear and damage and things like that, and one for color variation loosely, just to add a little bit more visual flair to certain elements. And you can see that all of those elements are just getting multiplied in, just like it's Substance Designer basically. They're getting multiplied in to our final models, so that they don't all look exactly the same using the trim sheet. So let me quickly if I just crack this open, we can actually adjust each of those individual values. So color variation, I could make this very bright and blue. And then if I go up to the color variation multiplier, you can see now I've got blue in all of those different areas. If I increase the dirt amount, you'll see that that dirt mask that we had in Substance Painter is applying even more. I can change the dirt roughness, just like it's PBR. And then same for edge wear as well. So we can increase the edge wear and change the color of the edge damage, like so. So obviously this looks kind of stupid and is not how things are supposed to be, but I hope that kind of illustrates the idea of a different way to use shaders. So we'll pass through all that and jump into another project. So now we've seen using the trim sheets, we've seen using kind of multiple UV sets, and then this is an example where we're kind of using trim sheets and multiple UV sets to create some fake detail. So this is a project that I was working on for Gavin, and one big component to working on this was that we wanted to make sure that these pieces could be made really quickly and really flexibly. And one key component to that is going to be the master material and setting up a proper shader workflow that works for all kinds of different situations. In this particular case, all of these objects are just driven by one or two trim sheets, and then all of the extra detail that you're seeing, like the coloration and the roughness and everything else, is actually being generated right inside of the engine here. So this is by far the most complex version of any of these little workflows that we've made, which works in some cases, works in some other cases. Really, it's going to be up to your kind of needs, right? You wouldn't build something this complicated if your textures were going to mostly be flat and you were making one-to-one maps for every individual asset. You wouldn't need something like this, right? But the idea with these shaders is we're building up all of these different channels, or building on top of what we're provided, before we actually pass these maps and everything into our rendered out material. So we can close all that and hop back into our actual project. So what does this mean for our actual project? Well, let's start by fleshing out our master material. As it is right now, we haven't really learned too much about what master material is or instance, and we've just been driving the maps in. This is fine for individual bases like this, but the problem is every time we make a new material, we have to repeat all of these steps for every individual object, and it has to get rendered out in its own pass once again. So instead of doing all that, what we're going to do is just create what's called a master material, and all of these other materials that are super basic will just be instanced from that master material with a few additional settings to let us change it. So I'm going to go ahead and make a new material, and I'm going to hit it with the prefix mm for master material. So we'll go mm underscore just base PBR, because these materials are all going to be PBR. I don't need to change anything here. All of this other stuff is going to be the same. But now, instead of dragging and dropping in our individual individual maps, I want to create parameters for each of our different textures that can be changed later. So if I right click here, it's going to bring up the search menu to bring all kinds of nodes in, just kind of like Blender nodes or Unity nodes or anything else that uses nodes. If I was to hold down certain keys, there are also hotkeys. So if I press S and click, it's going to give me a single scalar value as a parameter that I can name. So you can see it says param 0 and default 0. So it's telling me what the parameter value is and then what the default value is that I can change. If I press 1 and then click on the keyboard, it's going to give me just a single value. 2 is a 2 vector, 3 vector, 4 vector. There's some additional ones that are useful. There's a lot of math that's usually involved in these, so some common ones are A for addition and M for multiply. And then finally L for linear interpolation. So all very useful stuff. Generally speaking though, just for sake of ease, I'll search everything up as we go through so you get an idea of what it is I'm looking for. So the first thing that we need is to import a bunch of textures just the way we have. And I'm going to go ahead and start with texture sample parameter 2D. This is just going to sample any 2D textures. So in our case, our 2D textures, could be our trim sheet values, our metallic, our normal, everything else. And we can start with this. So I'll name this base color. We can go ahead and drag this into base color. For the first little bit here, it is going to look identical to what we were making, but things will change as we go forward. So now I can duplicate this with Control D. And then base color here, we'll change this to roughness. Control D, change this to metallic. Control D, change it to normal, or normal map. Metallic map, roughness map, and base color map. Okay. So we can continue just dragging and dropping our values in here. Metallic into metallic, and normal into normal. And then we'll sample our appropriate values here. Metallic into metallic, roughness into roughness. Great. So far, it looks identical to how it would have otherwise. And then I don't think we have an AO map here. We do not. Okay. This is where we start to actually add our additions. So if I'm going to just quickly drag this out, we want to give people as much flexibility as possible when they're using these materials. So an easy one that we can do here is just with the base color map, adding some option for tinting so that we can reuse the base color map, but maybe just tweak the colors a little bit and then reuse that to create more variation. So I'm going to go in here and right click, and I'm going to add a new vector 3. So a 3 vector. And then I'll right click it and hit convert to parameter. Okay, I'm going to call this tint. So because we kind of learned about this earlier in the semester, but every single one of these maps, right, it's just some numbers for each pixel, meaning we can do math to them. The same way that the black and white values are 0 to 1, for each color value, we're also dealing with 0 to 1, which is where we get our channel packing and stuff. Now, none of these are channel packed at the moment, but we can still multiply those values together. So if I take a tint and I take a multiply, if I right click this multiply, I can use start previewing node, and now it'll actually show up in my viewport. You can see if I go in here, I can adjust this and it will actually tint out my base color map. So by default, that's what it looks like. If we tint everything with a value of 1, right, it's going to multiply everything with a value of 1, nothing's going to happen. But if I was to, let's say, drag this to 0.5, now it's half as bright as it was. If I change this to more of a red color, then our material will be tinted more of a red color. Alright, anyway, sorry about that. Yeah, but where we were at, so adding tints to something, it makes it really easy to make all kinds of variations. You could make, well, reddish wood and then greenish wood. You know, you don't want to overdo this. Obviously, it looks pretty unrealistic right now, and all of the values for your dirt and everything else get totally messed up as well. But if we just add a little bit of tint, it's okay. It's not too bad at all. So we can take this multiplied value now, and instead of just dragging our base map right in, I'll stop previewing this, and I'll drag our new tinted value in. So this is just a small change that we can use that adds a lot. So the default value in the shader here, I just want to make sure it's set to 0. And I should clarify, I keep saying shader. So essentially all a material is an instance of a shader. That's all every material you build is. And in Unity, you have a lot less options for changing that. So what you're familiar with so far that you were building in first and second year, you're given the URP default lit material, and that's kind of it. You don't really have many options beyond that. If you know how HLSL, you can kind of get in there and tweak things, but other than that, you're pretty stuck. Here, we have way more flexibility, and you're actually required to build something when it comes to making these materials, so we might as well build something flexible. So that's tint. Let's get out of this way, and then we'll look at creating an instance of this and why we need to make these parameters, and then we can kind of keep going and make this more and more flexible as a base material. So I'm going to save this. Minimize it. And now from base PBR, I'm just going to right click and create material instance. And this one we can call mi_trim sheet. So we're kind of going to replace our existing trim sheet material here, right? Which is just those values, drag straight in. So we are going to come over here. Base PBR, we do have the ability to create a mask and use the opacity mask, just like the other one. So let's actually add that in as well here. Opacity map. I'll change this to the opacity. Okay. Shouldn't matter which one goes in here. There we go. I think it crashed. Alright, I will pause the recording again and come back when it's not crashed. Alright, where were we? So, I've got that material saved. If I head back in here, I can actually open up our instanced material here. And you'll see instead of getting a graph, we're actually just presented with a few options, those being the options that we allow to be seen from here. So everything that's a parameter, we're going to get access to it over here. So we have global texture parameter values and global vector parameter values, right? So it's just sorting them right now by type of data. What I want to do is keep things organized, so I'm actually going to go in here and start to clean up exactly where these things are in that hierarchy. So we have a few ways to do that. One is the sort priority, which is going to tell Unreal which order each one of these should be in within each one of their groups. So for example, I feel like roughness map should maybe be the second one here. I can pick an arbitrary value for the priority since it's going to be per group and all these textures are going to stay together. So let's just say we'll start the base color map at 10. This gives us some room below it in case we want to add additional maps and leaves a lot of room above it. Then for the roughness, we can go 11. For the normal map, we can go 12. For metallic map, 13. And I'll save this. You can see it's now ordered base color, roughness, and normal all in order here. So that's one way to stay organized. The other one is going to be groups. So each one of these can be sorted into groups as well and given a description for when you actually hover over it. So that's not necessary if everybody knows what's going on, but in the event that you're dealing with something like a large team and some people maybe are less familiar, it could be a good idea to go in and add descriptions for each one of these parameters just to highlight what it does. So let's take a quick look here for organization purposes. Where is it? Oh, here, group. So group is another one, and this lets us just create a group for parameters, which makes sense. I don't think that's super surprising, but the way it works is a little bit unconventional. In Unity, you make a bunch of flags and then you can set them to the flags. In Unreal, every time you type something in this box, so if I just type in texture maps now shows up as a group, and it's exclusively using this string value. So it's just based on what you type. So now I can come in, I can say, hey, all of my texture maps should be in the texture maps group. And now if we save, we can hop over and see that these are now listed under texture maps, which is a lot nicer than just having everything kind of floating all throughout. If anybody wants to use my shader or material setup, they'll know where to find the texture maps. And we'll create groups for the additional details as we go through as well. So right now we just have a tint, which is fine and dandy, but there's some other basic functions that we can give to the other things as well. The super easy one is to just add a scalar value. So I just hit the 1 key there, convert to parameter. We can just call this metal factor or metallic factor. And with another multiply, we'll just take this value and multiply it together with the metallic factor. By default, we want it to be 1, so it's the same as our texture map. But just in case there's some situation where maybe we decide we don't want any metallicness in a particular variation of the texture, we can find metallic faster, and if I pump this to 0, you'll see it loses all of its metallic value. And if I bump this to 2, nothing really happens since it caps out at 1. To make sure it caps out at 1 though, we can also come down to our parameter and set a minimum and a maximum. So a minimum, we probably want to set it to something like -1 in case you wanted to invert the map. And for the maximum, we could set this to 1. Right, and no values outside of that range really does anything for us, so we can kind of leave it there. So that's a really simple one. We can kind of do the same for the roughness. I'll just take these two, duplicate them, change this to roughness factor. And do the exact same thing. And it just gives us a little bit more variation. Normal map. There's not really too much that we can do to the normal map. And then opacity mask, same kind of thing here. There isn't really ever a reason that we want to adjust the opacity mask. So these ones are basically just considered good. We can kind of just slide them in here. And we just want to keep things mostly organized. All right, so here's our simple material. Let's sort the other values as well. So we can make a new group for our secondary options or something. Secondary details maybe. Or shader options seems better. Material options. The reason I'm messing around with it so much is you want to make sure you type it in right the first time, since like I said, it's using that string value. If I was to mistype it, I would have to go back and individually retype it into every single one. So doing it this way, just making sure it's all spelled the same. We can save that. And now we have even more options to mess with here. So I'll pick like some random wall value, and we can just slap this on. We'll put it on the roof too, why not? The scene was kind of lacking a lot of these elements. I wish I had more time to work on it, but with being sick, I just didn't get really around to it too much. We can open up our trim sheet material instance and change this to a darker color, for example. So by default, all of our parameters are going to hold their default values, and to change it, we have to check this little box off. So if I check off tint, I now have access to this, and I can change this to something else. So I can make this darker. You can see the changes are going to happen in real time. I can make it green, I can make it redder, darker, just to separate it into some different type of material. And when it renders, it's going to render this instance a lot easier than rendering an entirely new master material, since it knows that it needs to just render this exact same thing from the master material, but with different parameters. So it is much more effective in that regard as well. If you're curious about the materials you're making and how complex their shaders are and things like that, what you can also do is go up here to the view modes, and under optimization view modes, we'll find shader complexity, or shader complexity in quads. And you'll see it's giving us an overview of how complex each one of our shaders is. I think I want to do just shader complexity. So this was broken a little bit with Unreal Engine 5. In UE4, this all lines up the way it's supposed to. But essentially, any value that's closest to this green end here means the shader is about as efficient as you can get. And the further down we get, the more time it's taking to render that particular shader. So if we kind of look around the scene, we can see that the background is not too difficult to render. It shows up down here with what you're pointing at. And if we point at something like that instance that we just made, it's also relatively in the green. Right, so nothing too crazy going on here. You want to keep a good eye on this as you go through, because if you make something too complex, then obviously your game will start to lag. So let's press on. We can actually continue to work on this and do some other things as well. So right now everything is using, as we can see, this one UV slot, and it's going to default to UV 0. But I might not always want to reference the original UV set. And so we can kind of introduce the use of multiple UV sets here. Something that's pretty common is overlaying some kind of noise detail on top of everything else. And for that to make sense, we can use some kind of UV manipulation to either use a second set of UVs or do something similar. So I'm actually going to go in here and grab my UV coordinates, which is texture coordinates, and by default it's set to 0, which is going to be our base coordinates. And we can actually take this and drag it into all of our individual maps. So I'll just move everything around, take our text coordinates, and just drag these into all of our base maps, because all of these base maps should be using these values. Something else we can do is add parameters for the tiling as well. But I do believe it does that by default. So if I open up my trim sheet, No, maybe not. So what we can do instead then is we'll grab our texture coordinates, add a multiply value, add a new parameter, we can call this one texture tiling. All right, we can make sure that we add it to something as well. So here I'll go material options, and this one is pretty important usually, so I'm going to put it with the value of 1 to make sure it shows up at the top of that. And something you can do is I'm going to control click on this node to just move all of the connections up to this node. Okay, by default we want a value of 1. You can see if I move this up to 2, it's going to multiply how many times our UVs are shown. So now we're duplicating the number of times our textures are tiling. Oh, smokes. So you can do this individually for each direction. You could tile it in just the Y direction or just the X direction by using a 2D vector. So we can call this one texture tiling, where it multiplies the 1 and 2 values. Not sure why it's not letting me use a 2D scalar. So we could also split it up and make 2 and then combine them after. But for now, just tiling it in both directions is fine. So let's also fix our checkered floor by creating a new material instance, and this one will be mi checkered floor. And I'm just going to click each of these to change them for the checkered floor. So now we can find our checkered floor, checkered tiles, I believe it's these ones here. Base color, checkered tiles, roughness, checkered tiles, normal, checkered tiles, metallic, but I could also just use the slider here to zero that out. And then for the opacity, just find anything that is just straight white, which is apparently none of these. Okay, just a blank white pixel. We could also just add a part to our shader that lets us change this. So now we have 2 different material instances of very different materials, but they both are born from this original master material here. So we could replace, you know, on all of these, which will be a lot faster to do this way. We can just change it from our checkered floor to our instance checkered floor. Right? So it's not going to look any different, but now we have the ability to control individual elements of it. So if we don't like our tint, we can change it. Or if we want to change different things like the roughness factor, we can make it less or more rough. So leave that where it is. We can adjust the texture tiling. So you can see it's going to tile the texture more frequently. Which is all very useful stuff. So we've built up something good here. We can, of course, go in and grab all kinds of other information. I'll go ahead and just export this funky looking cube. into our engine. And actually somebody asked me last class how I was able to so quickly change things in engine. It's because I'm exporting directly into the project files. So rather than exporting to my desktop or something, like these are being exported directly in to the folders. So this is SM vertex color cube. And we'll import this. So slide this out of the way and we can pop our new cube into the scene here. And I just want to make sure that it actually has the vertex colors, because sometimes exporting them is a little bit weird because they're kind of old. So let me just quickly check. One of these should tell me. Maybe not, so we'll just have to find out right in engine. Paint. Okay. A little bit unusual. Alright, small hiccup there. Forgot to go in and change the vertex color import option in the actual mesh import settings. But now, as you can see, we have our vertex colors showing up in our object the way they should be. So I also just quickly changed it to be red, green, and blue values here. And those values we can easily grab from the shader and either just plug right into the color map or create different kinds of masks with it. So if I close this out, and I kind of get in here, just move our cube up in the scene. Now if I go into mesh paint mode, we can see our vertex colors are all applying properly. If you wanted to, you could even come in here and adjust this. So if I just set this to pure red and I come in with the brush, I can actually paint in individual corners. So this is going to be very useful if you're using vertex painting for creating secondary detail masks or anything else. Something very common in environment art is going to be to add a bunch of different sort of subdivisions. I'll show an example after. But just having random geometry filled into these gaps, because then it allows you to actually come in with the vertex painting and create a lot more detail that otherwise wouldn't be there. So I go back here and just get started with making a material for this. If I just throw our master material on, we can come into our master material and we'll just do a very simple effect of just multiplying our vertex colors onto the base color map. So if I right click, this one's very easy to find. You can actually just type in vertex color and you can see it's going to give us a slider with RGB values with any specific channel. So if I just start previewing this, right, it's all just white by default. This mesh doesn't have any vertex colors to preview, but we can actually create our own preview mesh. So I'll find the cube and then just click this little button down here that looks like a brick. You can see our cube is now the preview mesh. So we can preview the vertex color. We can actually just multiply it, for example, just straight into our base color here. So after the tint, we'll take our colors from our vertex colors and multiply them in here. And if we stop previewing, now you can see our wood actually is inheriting those colors. So I go ahead and save that now. I guess it's going to take a second. But you'll see our model in game, it's actually inheriting these colors, and we can go in and we can just take our brush and start painting those colors on as well. And the nice thing about vertex colors is they naturally sort of blend together. Because it's per vertex, it's going to blend and fade really nicely into other parts. So if we're using something like a detailed texture, or maybe we have a dirty variation of this texture, we can blend between them very nicely by using one of the channels as a mask. So we have essentially 3 extra channels here available to us to use. We could say that the red one, for example, is just going to work for the color, or the blue one maybe, like in the case of Skyward Sword. And then we can take something like the red one and multiply that into all kinds of other things to create different variation. So maybe we just use the roughness map as an example. I'll take the red channel and we'll just multiply this into the roughness map. And you can see how it's changing everything. So if I save that now and come out to our object, if I go into mesh paint mode and I paint in red, on everything, then it's going to have that default roughness value that we're expecting. Right. It's black because we took all the blue value out, so our color is getting a little bit mixed up. We can just bypass that though. Right, so you can see now it's normal, rough as intended. But if I go in and paint one of these corners out of that red value, change it back to white, and I take this corner, you see it uses the triangulation. But now that corner is affecting the roughness map differently. And we can check this by actually just kind of coming in here. And we can actually view just the roughness map. If I go to roughness. That was a terrible example because white obviously contains a full red channel. So let's make it black. And there we go. We can see that affects our roughness map, and now this side is actually completely slick and kind of blends in to the rest of our original roughness values. Alright, and we're back. One nice thing about this recording format is at least I can skip all the lengthy setup stuff. So let's take a quick look at what I just changed here to create a multi-material setup. So we're going to blend between different materials. I kind of mentioned this in class, and I mentioned again during Designer why it's important to sort of use these procedural tools. And here's a key reason why. So I went ahead and took our default cube that I had in there, and I just added a bunch of subdivisions. Not too many to the point where it's unbearable, but there are obviously a lot more here than there would be otherwise. Now, not every object is going to get this treatment. Mainly it's for things like walls, floors, and larger assets. Because obviously if we started adding this level of topology to everything, it would become very inefficient very quickly. So I've removed the vertex colors from this as well. It's just a flat white. And then in Substance Painter, I've just created a dirtier version of our trim sheet that we already had. So this is what we had going in, and then I just went ahead and added a bunch of layers of random detail just to make something that's similar but dirty, right? But it's still built on the same foundation. The reason it's good is because it means we can blend really seamlessly between this material and this material, right? Which is exactly what we're going to do here. So in Unreal, the last thing we need to sort of get this all going is, you can see I just created this secondary setup, and I've duplicated all of the parameters, renamed them, just put the number 2 beside them. You would obviously want to clean this up a bit more, and I would probably make this a second material as a whole, right? For demonstration purposes, I'm just using the same one, but you're not always going to want material blending by vertex colors. This is just for this demonstration. So you'd probably have one master material for base PBR and then another master material for material blending PBR. And that way you have both your bases covered, but you don't need to use the extremely heavy shader when you don't need to. So I'll introduce you to this new node. It's pretty simple. It's called Make Material Attributes, and as it sounds, it just makes a mini material out of your attribute textures here. So I've got everything sort of set up the exact same way as if it was going into the renderer, except it's just going into this Material Attributes node instead. So that just lets you cleanly collect everything into a single node, and I did the exact same for up here. I'm going to just get rid of the vertex color stuff that we did just to keep things clean. So we'll take our roughness map, and I'm just going to drag the original one back in here and get rid of the other stuff. I'm going to bypass the tint here for now as well. You would want the tint obviously to affect both of your base color maps, so you'd have to set it up that way. We're ignoring it for now. Just want to have the raw materials set up as they would be. And then last but not least, I'm just going to make sure that this is going into all of my nodes for UVs as well. In the event that I tile it, I probably also would maybe want to tile my secondary texture. Now, if this secondary texture was something like a noise, if I was going to be making like a rock and I wanted specific normal map detail in a certain area, you would probably want a secondary UV set or a secondary tiling option. So you could tile just the second material and not the first, but for now, since these two are working together, we'll tile it all together. So with both of our different setups, being the clean and the dirty, set up in our material attributes tab here, got one for each. We can also use this blend material attributes node to blend between them, quite simply. So if we go ahead and then break those material attributes after they've been blended together, we can actually map our materials back to our rendering tab here. Right? So we have each, we blend it together, and then we separate the now blended ones into the individual maps that we need. So you could do up to 3 materials, but for now we're just going to use the one. So I've got this scalar value in here just at 0. If I set it to 0.5, you'll see it's starting to blend that dirty map on top. Set it to 1. Now the dirty map is completely on top. Okay, the roughness value is freaking out a little bit, but that's okay. Instead of driving it by a scalar though, we want to drive it by some kind of mask that we make. And one great way to make masks is to use the vertex color. So if I now grab the vertex color, we can choose a channel and use that to create our detail. So if I go over to the red here, I just drop that into the alpha. You'll see, because the vertex values here are all white, it's just showing up completely as the dirty. So let's actually see what this looks like though on our new cube where the vertex values are not white. So you can see it breaks all of the other textures because the checkered texture doesn't actually have anything set up for this. Another reason why you'd want to make multiple material setups, but for demonstration this is okay. If I go into mesh paint mode here, and you can see that this is painted completely black. As a result, it's using only the original texture. There's no dirtiness to this at all. I want to make it a little bit easier to see, so I'm just going to tile this up. There we go. So now what we can do is actually go into our mesh paint, and we're using the red value, so I'm going to go pure red, R of 1, G, and B still 0. Click OK. Instead of viewing the RGB channels, I'm going to go ahead and click off, so we just view the actual texture. And now you can see with all of these extra vertices, I'm getting way more options and areas that I can paint. And so now, if I start painting on this tileable texture, you'll see I'm actually blending in the dirtiness, the edge wear, and everything else that comes with that dirty texture. So I could have just a pocket that's dirty here, maybe a certain area that makes sense for, you know, foot traffic maybe, or I could dirty up just more or less everything. But I have so much control now over where my dirty areas are, right? You can see me painting on edge wear. And because it's all tied to a channel, we can make even more variation by just kind of reducing our value here. So if I set this to a little bit less red, 0.5, you can think of this as like opacity. So now as I paint, it's not as aggressive. And I have to do a second pass or third pass to really sort of fully paint that in. And I can do this for every single channel, so I can make another one for blue. Right now the blue doesn't do anything, but if I was to just go pure blue, it's fighting with me here, pure blue, right? You'll notice that even though I'm painting now, nothing's showing up. But we could add a second material or a third material or some other detail mask and just paint those values on using this very simple setup. So this is incredibly useful. It's something you absolutely will have to get used to using if you're using any tileable textures, which you will. This would have been way better set up on the checkered floor material than on this material. You'd be able to see it a lot more clearly and it would make a lot more sense. I just didn't have the time. Maybe that's something we can explore on Thursday though. So switch this back, go red, paint it on, and then we can go black to erase. Or I believe it's shift click to erase. So now I'm just erasing all of the parts that are dirty. So this is where the environment art aspect really comes into things. This is what makes or breaks your environment. It's how you add detail, it's how you add storytelling. It all comes down to these little ways to break up the monotony of especially our tileable textures, because these textures are all over the place. This really allows you to break up your environments. Okay. Very simple setup. We can check the render weight here by just going to our optimization view. And shader complexity, you can see it is not too complex at all. Definitely a little bit on the darker green side, but again, this wouldn't be applicable to every single material, just something like this, maybe like this trim and maybe the other big tiling materials, but there'd be no reason to have this on something like a bottle or a wine rack or, you know, the fridge or any of these other smaller props that are going to be in this scene, right? So this, for what it's worth and for what we have going on, is working pretty well. It is not too expensive. Okay, it's no more expensive than the default mannequin rendering. Alright, so that's vertex colors. The next one is a similar premise, but it's just in the event that we want to create our own masks inside Substance Painter, we can still use RGB values to do it, but for that to happen, we do need to go ahead and tweak a few settings just to make it more visible. So I'll get that set up and then resume the recording, and then that'll be the last little section of this. Alright, we're back with our final and last setup. So all the extra vertices are gone. I've got a UV map that's set out for trim. So this is meant to use our tileable trim sheet, and in Engine it just looks something like this, quite simple. But let's say this is an asset that needs a little bit more detail, but doesn't quite warrant the extra geometry and getting in there and vertex painting everything. Maybe this is a prop or something where we want a little bit of variation, but we don't mind if that variation is kind of repeated between props. So what we're going to do is create custom RGB masks that we can use. And to do that, I just have a new Painter file open. We can see there's a problem here because our textures are overlapping. And they're different sizes, all meant to just sort of work on the trim sheet. So this is where we have to get into using multiple UV sets. Every object, as you know, has some UV set by default, the UV map, but we can actually pack more data in and add additional UV maps. Now it's a little bit funky with Substance Painter here. As far as I know, Painter currently only allows you to paint on the first map. So if I was to import this with 2 UV maps, it's always going to just default to whatever's in the first slot. But in Engine, you would probably want your trim sheets to be on the first slot, your details on like the second or third, and then your light map would be in one of the other ones. So we don't want to interrupt what's going on in Engine as much as possible. So what we're going to do is just quickly add a new UV map here. And we can call this one RGB mask. So we have one for the trim sheet, that's going to stay the same as it is. And we have another one for the RGB mask. So if I click on RGB mask, I can actually take everything here and just unwrap it and have it all in its own space, just trying to make use of as much room as possible. You can see up here it says which UV channel I'm in. So RGB mask, great. So this is what we're actually going to want in Painter. Now to do this, it's a little bit funky. Blender at the moment doesn't let you move these around. If I want to reorder them, I've either got to use an add-on or something like that. So if I hop into UV Pack Master, I can actually change where my UV maps are. But it is all in all a little annoying that Blender doesn't let you do it by default. The other option is if we go up here, there is an add-on that will allow us to adjust these UV slots. I thought I already had it installed, but apparently not. And let's see. Yeah, this one right here. So UV Maps Plus. So if I install this one from the extensions, it is going to allow us, oh yep, that's the exact one. So now we have the option to reorder these UV maps, as well as a few other additional settings which are useful, but the main one here is that we can reorder them. So I can go ahead and take our RGB mask, move it up, and now it's in the first slot. And when I export this, it's going to break in Engine for a moment because now our trim sheet is sampling the wrong UV set. But if I re-import into Painter, I have everything I need now in Painter to create a one-to-one mask. So I can just quickly flip back, change this around, re-export this back into Engine. Now we're good to go here. And it just won't re-export in Painter. We'll just go with what we have here. So now that that's set up for the model, we don't actually need to use any of these PBR maps. That's not what we're interested in here. We just want a bunch of black and white maps that we can use to create some kind of RGB mask. So under channels here, I'm just going to nuke everything. And we'll make our own. So we can actually go in here, user channels, and make whatever we'd like. If I go user 0, oops, user 0, we'll add user 1 and user 2. We can rename these and change them as we need to. So by default, they are all set to 32-bit linear textures. We're going to change them to 8 bits. We don't need that much detail. And then just want to make sure that color channel is checked off, because each one of these is technically a channel, but we're going to pack them all later at the end. So this will be our R channel, and we can call this one something like dirt. This one will be our G channel, and we can call this one something else. Edges maybe. And the final channel, blue, we can go with color variation, for example. Really what you put in these is totally up to you. You can have this for your material blending. If you have a bunch of tileable textures, maybe this is a mask and you have a different dirt material. Really the possibilities for RGB masking here are endless. This is just a pretty common set, but you can run whatever set you would like. So I've got those 3 maps set up. You can see here we view them one by one, single channel. We're not going to see normals, we're not going to see color because we just got rid of all of that. We're not going to see the material as a whole, but we're really not interested in that. I just want to come into each individual channel and create some sort of mask for it. So let's make some mesh maps here, just so we have a little bit more to work with for our generators. I'm going to use low poly as high poly and just bake it out, just to sort of get our edges and things like that a little bit. So we'll hop back in here. Great. Now at least we have a curvature map, though it's not very good, but we have something that we can kind of work with. So under dirt here, we can start to make dirt just like we would anything else. So I'll make a fill layer, right? And I'll get rid of the other channels. I just want the dirt channel, and then we'll add a black mask. So just as if I was doing like a roughness map, except I'm making a dirt mask specifically. So we can use a generator and just fill it with dirt here. And then if we hop into the dirt channel, we can see how this is actually affecting things. Right, if we wanted to make an empty base for it, we can just hop in here, and I'm just going to make this pure black. Call this base, and this is our dirt mask. Okay. So this obviously doesn't look that good, but it's here as an option. I'm going to add a filter. Let's see. Shadow gradient, no. Let's add a generator. Use the light generator to sort of grab our position. And we'll just change this. Oh, that's not going to work. Position. There we go. So I'm just going to invert this one. And I just want a lot more dirt build up near the bottom of the object. That obviously would make a lot more sense here. And we can add a texture as well. I can find some kind of texture to just sort of help blend everything together. There we go. This is just a little bit nicer as a whole, and we'll just set this to multiply. There we go. So I've got dirt kind of coming up from the ground. I could continue to work on this. Use a paint, grab a nice brush for this, something a little bit softer with a low opacity. Let's go artistic heavy sponge maybe. No, that's too much. And just tweak things as you go. Let's say we're happy with this as our dirt mask. We can kind of move on to the next one. So we can wrap this up in a folder. We'll leave base outside of the folder because this should be everything. We can move on to edges. Set a new folder, edges. And do the same thing. We'll add a generator with a curvature. It's a little bit busted because our curvature map's no good. This is only affecting the edge channel here. Alright, not great, but let's just say that's our curvature map that we want to export in. And then the last one, color variation. I'm not going to do anything with this. Don't think we need it. I think I just forgot to take that off of the fill. It's unusual. Oh, I'm in blue, not green for edges. There you go. That makes more sense. Okay, and then color variation, we'll just leave that blank. So I now have my own channel set up. I've got each individual mask made out. I can export this any way I like. We can call this RGB mask. And then export it to the engine. But one thing I do want to do is I'm probably going to be using this setup a lot for all kinds of different objects. So what you also want to do is go into File, Save Options, and just save as template. You see I've already created one RGB mask template, and just that means next time I make a new file, instead of using PBR metallic roughness, we can find our new RGB mask template, and then all of this with the channels and everything is already set up. So to export to engine, we do have to do a little bit of work here. If I go into my export settings for export textures, you'll see that obviously none of the default templates work for what we're trying to do. We're not exporting PBR maps. There are no PBR maps. So what we actually have to do is make our own. You can see I've already got one in here for RGB masks, but we'll make another one here. I'm just going to hit the new button, new export preset. We can call this one RGB mask. I'm just going to rename. And then we get to choose exactly what our outputs are going to be and where we're going to get them from. So if I go ahead and start with an RGB, we are actually doing an R plus G plus B because we have 3 individual maps going into 3 channels. So if we go just RGB, it's going to combine them. R plus G plus B allows us to move each one of these into each individual map. So down here we have our maps that we can export. We're looking for user 0 since we have that set to red. For the dirt mask, you don't have to label it here, you can label it later, but we know that this gray channel is going into the R slot. User 1 is going to be our edge, gray, and then user 2 is going to be our blue. So in here, gray, and now when we export, it's going to combine all of these different masks together. So one more thing that you should do when you're exporting like this is use the regular expression stuff. So if you type in a $, it'll pop up with a few options for data that's already in the scene that you can use. So if I just go in here, I can type in $mesh RGB mask or RGB. And we can save this as our export settings. And when we go back to our list of exports, so RGB mask 1, list of exports, you see it's just the one. It's grabbed our object name and then added RGB. So let's go ahead and export that right into Engine. Content, textures, cube, we can select that folder and just export everything here. You don't have to actually label these as red, green, and blue. You can just label them dirt, edges, and color variation. This just helps me understand where exactly in the texture they're going to end up final, but since we choose where they go, we can change that at any time. So we have a little bit of a mess here since we've got so much going on with all this material blending and everything. I'm going to just quickly nuke this. We'll go back to the way things kind of should be. So I'll just go 1-to-1 from our basic material. And just delete this node as a whole. Okay, so we're back to where we were, which is great. And now we actually have to start paying a lot more attention to this. So I'll change this back to 1, or rather just get rid of it entirely. So we have a clean slate. So up until now, everything has been in UV channel 1, which for the most part has worked just fine for us. If we open up our mesh, we can actually preview these UV channels. If I go show UVs. So I can see UV channel 0 is our trim sheet UV. We can see UV channel 2 is our light map pack UV for the light maps. It's automatically generated by Unreal. We didn't do anything with that. And then UV channel 1 is our other made map for our RGB mask. So now we want to sample UV channel 0 for the trim sheet and UV channel 1 for the RGB mask. So let's go ahead and do that quickly. We'll leave this as it is and just create a bit of space. We don't have any dirt material, so I'm just going to multiply it into the roughness and color map. But we'll grab another texture coordinates, and this time we're going to sample UV channel 1 instead. I'll duplicate the base color map quickly and just switch this to RGB mask. And then put our RGB mask in here. Sample UV channel 1. So by default, the sampler type is color. We are actually going to want to change this to masks. It means there isn't going to be any blending between the channels, which is what we want. And then on our actual texture itself, we have to tell it, hey, don't compress it between channels. Compress it as masks so that you're compressing each channel individually and they're not fighting over one another. So now for sure we get all of our data at the highest quality possible. And if I go ahead and preview this, awesome. Our masks are showing up the way they are supposed to. So I can stop previewing this and we can start multiplying things together. I'll add just a vector 3 here for some kind of dirt color. So we can get this dirt color and organize this into our groups. And maybe we just go with a dark brown. And then I want to multiply these together. Or lerp them together. I think this will give a better result, so we'll do this. The red channel is our dirt, so I will just drag this into the alpha. It's going to override whatever values are underneath, so we want to be a little bit careful with the lerp, but as long as we provide the maps in the proper spots, everything will be fine. So now if we lerp this into the base color, you'll see we're getting dirt and stuff over top of where our masks are. So the B value, I don't remember which way these are supposed to go. For this to make the most sense. So we're just going to trial and error here quickly, but I think this is how it's supposed to be set up from what I'm seeing. If I just quickly change this to bright red, that'll help us obviously spot what's going on. There you go. Yeah, so this is the way you should be having. So let's move that back down to some more dirt-like color. Okay, and also just, you know, the way dirt is, we're just going to duplicate this setup, and dirt would also affect the roughness channels. So I'm going to do the exact same thing. We'll just add a scalar value for the roughness. Dirt roughness. You can set it to 0.7 for example. And just slot that in here. And then take our original roughness and slap that on top. And then this will go into roughness. Okay. And we can have it go through the factor. Okay, now you can see our dirt is kind of showing up here. Obviously it doesn't really work on this object, but it's going to work a lot better on our multiple UV objects. So this would be a third type of master material. So now I've kind of gone over 3 different master materials. I did it all in the same one, but you would ideally have a library of different master materials for different niches. So for RGB mask materials, you'd have a master material. For multiple material blending via vertex color, you'd have a second master material. And for your basic PBR, basic trim sheet stuff, you'd have a third master material that you could instance from. So let's take a look at this here now. We can see we still have the trim sheet texture on, but we can also see that dirt mask kind of building up on the bottom of the object here, right? So it's happening independent of our trim sheet. And if I go ahead and just take the material and we crank this to something like bright orange again, just to get a better look at things. You know, we can really start to see how this mask is going to be useful to us. So this, again, the main thing with all of these different shaders we've been trying to do, we're just trying to build up a way to reuse these tiling textures as much as possible, these repetitive models and textures, and still have variation in different ways to break them up. Because obviously if your entire scene is just made of these tiling textures, eventually things are going to be pretty boring. Again, you can see it's breaking everything because I'm just using the same master material to do everything, but ideally you'd have some other setup, right? So I could go into all of these props that we've worked on so far individually, and I could add RGB masks to them if I really wanted to get in there and add more detail, right? We don't have unique wraps for these, so they don't have things like individual normal maps. But at the very least, we can give them a little boost with an extra dirt mask or something of the sort, right? And we can even combine these. So I could have a dirt mask or a dirt texture and vertex painting and just sort of be able to paint in both. The possibilities really are endless. Hopefully this has been a good overview and you can think of a few ways to use these techniques or processes in your games. If you have any questions, you can reach out as always. and I will see you guys on Thursday.